All right. Thank you very much. My name is Steve Harpster. I'm a solution architect for the grid team at NVIDIA. Craig, I'll let you introduce yourself.
So I'm Craig Fullman. I actually reside here in Southern California, and I do business development for the grid technology here in North America. We appreciate the chance to meet with you.
And how many of you guys were at Synergy, just out of curiosity? Yeah, that's what I thought. And another question for you guys, how many of you guys are administrators of your corporate network or infrastructure for VDI? How many admins are in here? Wow, so this is all users that we've got here, is that right? Or almost all? Okay. Or consultants? Okay, good. We wanted to know how to focus down on some things, so that tells us a lot. So I'm not going to spend a lot of time going through the actual, I mean, what I want to do is just spend a little time here, not a whole bunch, but does everybody kind of understand what a GPU is and what a GPU brings to virtualization, first of all?
I think you can go deep pretty quick.
Excellent. Okay, so an obvious advantage is shown here. This is without, that's with, that's SolidWorks RealView. And in a critical design review, having that much more detail as people are going through things, especially in a virtualized machine, really can help out. So real quick, what are we offering today? We were offering 2 grid cards today. A grid K1, which has 4 entry-level GPUs on it. Each GPU has 4 gigabytes of dedicated frame buffer memory. Single slot card, double width though, okay? And the NVIDIA Grid K2, which has 2 very high-end, equivalent to the Kepler 5000 card that's out today on the card. Same form factor. Couple of speeds and feeds real quick here. As I said, single by 16, double width. These are passively cooled, so it requires servers that allow you to have the proper airflow and the proper SBIOS that's been cooked by the OEM vendor. So it doesn't fit into anything out there today. You have to go with a list of certified servers. But notice that we're drawing 130 watts here. So you're going to need a 6-pin connector coming off your power supply. On this one, we're pulling 225, so you need an 8-pin connector coming off of there. Depending on the model that you're using, and I'm going to spend some time on this slide, that frame buffer memory or graphics memory that's on the card can be used as a pooled resource, or it can be used as a dedicated resource, or it can be sliced and diced up. So I'm going to go through some of the different options. Is this too basic for you guys, or do you want to go over the different models, I guess, is what I want to know real quick on what we're doing with virtualization. Okay, I'm going to proceed like you guys want to do this. So we basically got 3 modes today for virtualization. The first one we'll talk about, you guys probably have known and loved for the last 2 or 3 years. AMD's got cards that can go in there. NVIDIA's got cards that can go in there, and this is your traditional pass-through configuration, meaning XenServer or Citrix, VMware ESX, you take a GPU and you pass it through in its entirety to a virtual machine. And on the virtual machine goes the actual graphics driver in the virtual machine itself. So in this case, on the far, your guys right, the GPU, all the GPU memory and all the GPU cores is being dedicated to a single VM in a 1-to-1 ratio, okay? Been there for the last 2 or 3 years. AMD's got cards, we've got cards. You guys have probably played around with this some. This side of the chart over here on your left is a shared graphics setup. And in this case, I'm going to highlight VMware VSGA. XenApp, we'll talk a little more about. It's a little bit different model, but for all intents and purposes, in a shared environment like VMware VSGA, I'm taking the GPU or multiple GPUs in our case, where you've either got 4 or 2 GPUs to work with, and those GPUs are seen in a round-robin kind of basis, and you're pooling the resources together. So all the frame buffer memory on this card, let's say a K1 that has 4 per GPU with 4 GPUs, is going to have 16 gigabytes of frame buffer memory to work with plus 4 GPUs that can be used in a round-robin fashion. So in this case, you would enable 3D within your virtual machine in VSGA setup. First user comes in, gets some resource, second, third, fourth, up to, we'll show you some benchmark numbers. We're going to use 15 to up to 15 users would maybe use those GPUs and all that frame buffer memory in a round-robin fashion, so to speak. That's what we call a shared model. Everybody good with that? Any questions? Okay. The third model that we have announced with VMware, but we're currently shipping with Citrix, is something called VGPU. And this is a model where I can take that single GPU or one of the GPUs on our multi-GPU cards and further carve it up into specific amounts of frame buffer memory per virtual machine. I'll explain it further as we go here, but take that single GPU, maybe I want to give 1 gigabyte to my users. In that case, I would take that single GPU that has 4 gigabytes dedicated and slice it up into 1 gigabyte chunks. So I'd get 4 virtual machines on that GPU, and each user on the VM would be guaranteed a 1 gigabyte amount of memory from the GPU. They're sharing the cycles and the CPU cores, but they're getting a dedicated amount of memory per GPU or per VM. Okay, that's called VGPU. It ships today with Citrix. And it's coming, we'll have a beta with VMware coming up December timeframe. That's what we're hoping for, right? Okay. I'm sorry, can they? No, right now you have to dedicate, it's not dynamic at all. So if you want to reallocate, you actually got to physically shut down, reallocate a profile on that particular VM, start it back up. So if I answered your question, I think that's what you were asking there. Anything else on that? Okay. Now, this is a bit of an eye chart, but I want to explain to you how VGPU works today with XenServer. So, grid K1, K2 card goes into your server. You got XenServer 6.2 Service Pack 1 is the requirement today. And on top of that, you're going to put a little tiny RPM from NVidia called a Grid Virtual VGPU Manager. Okay, that goes on the host itself. In that case then, now we've got a direct connection down to the GPUs in the server, and so I can get direct access like a pass-through type of config, only it sees both or all 4 of those GPUs as different enumerations on the PCIe bus, so you can tell which one you're using, okay? Now, from the standpoint of the virtual machine now, we take that 4 gigabytes, we chop it up into a 2 gig chunk, a 1 gig chunk, a 512 meg chunk, or a 256 chunk. Those are what you get today. That gives you, pass-through obviously gives you 1-to-1. 2 gigs would give you how many virtual machines on a GPU? 2, because there's 4 gigs, you're dividing in half. How about 1 gig? How many you get? Perfect. 512 and 256. No, you still get 8. So today you're only going to get 8 maximum, even if you go with that 256 megabyte profile, okay? So you see how we're kind of slicing it up. Which the logical question is, can I get more? In the future, yes, you'll be able to expand that 256 probably to 16. We just wanted to be very conservative with our first release, so we're maximizing it at 8 virtual machines per GPU, okay? Now, so you carve that chunk of frame buffer memory, you dedicate it to a virtual machine, and then it's just like your pass-through setup where you have to have an NVIDIA driver on the virtual machine itself, okay? Is that kind of clear what we're doing there? Questions? Okay. So now, I think this has a bunch of transitions, so let me just go right through it here, guys. It's easier to talk about if it's all up there. Now you can share that GPU that you've got there. You got physical management of the GPU on the hypervisor level or on the XenServer level, and then from the VMs you've got direct access down to the GPUs itself. All right, yes. Other hypervisors. I will talk about other hypervisors in the next slide. There we go. Okay, so I told you that we support XenServer in some form or another. We support ESX in some form or another, VDGA, VSGA, and we support RemoteFX as well with their RemoteFX driver. Now, why in the world would I not just use a VSGA setup to share my virtual machines today? Does anybody know why? Okay, does everybody know what that means? Okay, API intercept. Thank you, Dane. That was a lobbed softball right there. So what we, I guess I want to go to this next slide here. Actually, the next one. Here we go. This is why. An API intercept is basically saying I'm not going to use an NVIDIA driver to talk to my GPU, is what it means. So in the case of VSGA, I'm using a, sorry, that's my phone. I'm using a VMware driver in the virtual machine to talk to my GPU. So since I don't have direct access or an NVIDIA call down to that GPU, I have to intercept the calls, retranslate it, put it back up to the virtual machine. Not a big deal. It works pretty well. RemoteFX works exactly the same way. Here's the big difference though. Can anybody spot it on the chart what the big differences are here? OpenGL, that's right. Does everybody know what OpenGL is and what DX is? Okay, good. We won't explain that then. So while the shared modes on RemoteFX and VSGA work really, really well, in specific cases, they don't work in all cases. So if I'm running Office apps, that's a DX application. This RemoteFX setup is going to run awesome. It's a DX application. If I'm running Office apps or I'm running Autocad, does anybody know if AutoCAD's an OpenGL app or a DX app? No, it's a DX app. So that was a trick question, I think. So while it will run in this particular scenario, what if I'm running Pro-E? Is that an OpenGL app or a DX app? Anybody know? Or CATIA or SolidWorks? They are OpenGL applications. OpenGL in its current form today is at Rev 4.4. So while SolidWorks and CATIA or Pro-E or some of these big design applications may run, because I don't get OpenGL support up to 4 point whatever, the current one today, I'm going to fall back to CPU rendering. So I'm really not taking advantage of the GPU as much as I want to there, okay? So these work awesome in specific situations with specific applications. You just got to know the apps, you got to know what graphics API calls are being used to be able to determine which one's the best fit for you. So what we did is with, and let me back up here. If you use pass-through, and that's VDGA or pass-through today or VGPU, it supports all of the OpenGL versions and all of the DX versions today. So there's no problem with VMware's VDGA solution at all. You can run an OpenGL 4.2 app on VDGA. But if you're running VSGA, you just got to know the limitations of where you're at with the actual API intercept, as Dane said, with the VMware driver or the RemoteFX driver versus an NVIDIA driver that's up in the actual VM itself, okay? Is that kind of clear for everybody? Does that help answer some questions? Okay, are there any questions? All right. How are we doing on time here? Fine, I think. Okay. So a real quick look at just those vGPU profiles that I talked about earlier. And how we're going to slice up the GPU today, if you go down the path of VGPU to get better density rather than a 1-to-1 VM to GPU ratio. Here you can see the profiles that we're offering today with the VGPU solution. Multi-monitor is a big question. We can do 2, but there's only one profile that allows us to get multi-monitor support, and that's the Q, or the Case 260Q that you see will support 4 heads, okay? Anybody know why it's difficult to do multi-monitor support? Because think about it, you got multi-monitor, you're pushing a lot more pixels through that pipe, aren't you? So you need more graphics memory basically to do it there. Yep.
So what is a virtual display?
Meaning on the GPU itself, there's no physical connectors, right? You're using a virtual machine that has a virtual display. So what that means is if I've got a client device that I want to connect into with 2 or 4 monitors, meaning here's my laptop or my workstation or whatever I'm using, I got 4 monitors. When I connect to the virtual machine, I'm guaranteed to get all 4 monitors lit up on my actual client workstation or system that I'm coming from, okay? So a virtual head is just how many monitors are going to be seen at the end device with these particular vGPU profiles.
You have, you said the K2 has 8 gigs, right?
K2 has 4 per GPU. In a shared mode, it would have 8 total to work with, yes.
So it has 8.
Yep.
You're saying the frame buffer is 2 gigs.
Correct.
So in theory, you'd be able to get 4 users across 8 gigs, but one user has 4 virtual heads. You only get 2 of those users?
No. Each VM would have 4. Each virtual machine is guaranteed 4 display heads with 2 gigabytes of memory there. Okay? Yeah, good question. Thank you.
Can you talk a little bit about
Great, good question. So in today's current release, let's take the K2 because it's easy. I got GPU 1 and I got GPU 2, right? I can put the same profile on this GPU and the same different profiles on this GPU. I can't, so for instance, if I wanted to use a K260, I could get 2 VMs on this machine, and if I used a K240, I could get 4 GPUs or virtual machines on this GPU. I can't say I want a 2 gig and a 1 gig machine to run over here. They got to be the same type of profile today on each of the GPUs. Great question. Thank you. Okay, anything else? All right, so now I'm going to turn it over to my esteemed colleague, Oh, the demo will, do we want to do a demo now?
You guys want to see a demo?
Demo! Okay, let's show a demo.
Take a chance to do a demo.
Damn it, Craig, why did you bring that up? No.
Did you bring the Oculus Rift?
Of course I did. All right. Let me show you what I've got here. So I have logged in. Oh, it did not. Oh, I got to go out of PowerPoint, don't I? Okay, hang on, guys.
This is the Windows 8 it won't leave PowerPoint unless you're.
Now I got to tell the real story. This is an old laptop. I was using XP, and every account I went to, they were making fun of me. So I finally upgraded to Windows 8, skipped 7, and I have no idea how to use it now. So, that's the problem. All right, so what I've done is I've logged in previously to a virtual machine that you can see here. And by the way, if you guys want to do this same demo or go in and look at this, this is a tri-grid demo that's set up by NVIDIA. You register, you download a small little client, and you launch it. And it's a non-persistent desktop, so you can't save anything to it, but at least you can get a feel for what performance comes with a GPU on your own.
And I think.
Tell us what protocols you use in that.
Who would ask that?
Yeah.
Dane Young would ask that, wouldn't he? Okay. We are not using ICA. We are not using PC over IP. I will admit. This is a homegrown protocol that NVIDIA is using right here. It is a VCA unit. You are absolutely right. So it's a box that we can control on our network. But it's the same hardware. It's a XenServer underneath the covers, just a different remoting protocol. Thank you for asking that, Dane. Should have paid him off, man.
For this audience, this trial grid is just brand new this week for Synergy, and it's available in North America. We will be adding it in all the other regions as soon as we get the center set up. So
Yeah.
just caution you about that.
So you can see it's my virtual machine. You may not be able to read it, but at the top there, and I think I can read that too. We're getting 65 milliseconds of latency, 30 frames per second, and 400 kps right now. kbps, yes. So what kind of bandwidth do I need good question. Watch, can you guys read that third number up there at all? No, you can't read it? Okay.
We'll read it for you then.
Okay, so we're at 470 kbps right now. It's just sitting there. That's all it's doing.
That's the capacity we're getting from the cellular connection that we're using to the internet, because we're using a cell phone tethered.
Yeah, I'm tethered. Right here's my connection, folks, okay? Okay. So this is a Verizon 4G LTE, and this is a model that I've got, and this is an app called TC-Viz, Team Center Visualization. It's a Siemens product. It's used to take CAD data and bring it down in for visualization on downstream users, so to speak.
Rotate as fast as you can. We're up to 3 megabytes per second.
3
megabits, I mean.
Megabits per second.
Per second when we're rotating.
25 frames, 30 frames, 80 milliseconds of latency right now, okay? Everybody got the picture? All right, so that's just one app we thought we'd show you. Now, I can bring up Autodesk, hopefully, and we'll see what that looks like. So I'll launch Autodesk. This is our Autocad 2014 now. Takes a minute. And, you know, we're still at 67 milliseconds latency, 25 frames per second, and I'm at about 117 kbps right now. Here's Autocad. Dang it, how the heck do I get my orbit thing now? Let's see, I think it's in here. I'm not a great user of this, so I apologize. Well, yeah, maybe it'll be there. Let's see. Yeah, there we go. Okay, view, set perspective. All right, so you can kind of see, and I apologize. I wish, oh, here we go. This is what I want. Steering wheel, there it is. Orbit. So this is the Stadium model that you guys may have seen at some of the Autodesk and from other shows. And again, now I'm going up to 4.8 megabits per second, 30 frames still, 97 milliseconds. So the latency's going up and down a little bit here, okay? So that's Autocad on the grid cards themselves, okay?
How many of you have either users or clients that use CAD applications, Autocad being a proxy for that? Okay, good, thanks.
Okay.
So our goal is for Grid K2 to give a like local workstation experience in a CAD application, right? That's a primary market where we sell NVIDIA Quadro graphics and PC workstation. Grid should be the equivalent experience in a VDI session.
Even HTML5, it's going to be accelerated. Take advantage of the GPU that you see. This is just a web page that I'm at right now, okay? All right. Okay, now I will turn it over to my esteemed colleague here. So back to PowerPoint. Death by PowerPoint. Oh, yes. I can get them to you, no problem at all.
Yeah, these are available.
Oh, okay. Great.
So this is a set of benchmarks that were done by our good friends at Dell, and they're published. You can get this document. They did some quick tests where they used login VSI to create a user workload environment. So the column on the left is VDGA. VDGA with a dedicated, graphics should give you your best experience. So they ran on the Grid K1 board 8 simultaneous users, so you've got 2 K1 cards and a Dell R720 server. They're getting about 12 frames per second running their benchmark in this mode on 2 K1 cards with 8 simultaneous VMs, so it gives you a feel for what sort of performance they're achieving. We consider that interactive graphics for a CAD user should be at 15 frames per second or higher. That's the standard we generally use for interactivity for an engineer to be productive. The next row down is the Grid K2 card. You see that the VMs there, you can only have 4, of course, because you have 2 processors on each K2 card, so you got 4 processors, are getting 56 frames per second. So that's clearly going to give you a like local workstation experience if you can operate that way. And we have quite a few customers who are buying the VMware solution with VDGA and running GIS and other high-end applications where they would have bought an expensive workstation, typically $6,000, $8,000 per user. They're thrilled to be able to do this on a server and share that $24,000 server for 4 users. And hopefully your organizations get a discount, and so it'll be even less cost to you than that. So they're seeing this as kind of a good value proposition relative to buying workstations, aside from all the other benefits you understand about VDI, which you get anyway. In the right-hand column, you have VSGA, so this is the mode where you're not running the NVIDIA driver any longer. You're running that API intercept driver from VMware. So they ran a knowledge worker, login VSI type of script. In this environment, they're saying that you can support about 18 VMs on a single server with 2 of the K1 cards. And if you notice the next row down, you go to Grid K2 cards, and you get 20 VMs. So what you're discovering is that you really pretty much hit the CPU limits of the server to support that many simultaneous VM users, no matter how much graphics hardware you throw at it. You're really going to run out of CPU resources before the graphics becomes your constraint. When you've got a Grid K2 card, it only gave you 2 more users on the server. So it's important to kind of recognize what's limiting your application. Are you network bound? Are you graphics bound in your performance? Memory or CPU bound, because you need to optimize where your real pain is. The same data just presented differently here. You see that a Grid K1 card is about 1/4 the performance of a Grid K2 card, and there's a whole set of different applications being benchmarked. They all have different performance because of the way their app is written and the way it manages graphics. But the fundamental message is that Grid K2 cards are going to give you about 4 times more performance than a Grid K1 card. So if you're trying to figure out, do I optimize for density or performance, just be sure you don't go so far towards density that the users walk away and the VDI project, comes to an end. That would not be a desired outcome. This is a different benchmark with Autocad. Cadalyst has been published for many years as an Autocad benchmark, so a lot of our customers are using this right now. This is actually a customer data. We didn't run this benchmark, the customer did. On the left, you see a physical workstation. So that's the fastest you can possibly go, is to buy a Dell workstation, stick in a Grid K5000, that's our Quadro, a Quadro K5000 graphics card. That's the same actual chipset that we put on the Grid K2, so that's why we tested that card. So we're calling that 100%. That's as fast as you can go. The second column over is the dedicated GPU or GPU pass-through. So that should give you your best user experience, but you take out about 12% overhead to run XenServer and XenDesktop. Now, most people think that's pretty reasonable. I'd give up 12% to have a hypervisor and virtual machine environment. And if you think about where users are coming from, they've got 2 or 3-year-old PCs that are due for refresh. They had either old Quadro FX cards in those or the previous generation Quadro 4000 cards. This is going to be an upgrade for them. If they get a K5000 class processor shared to 2 users, that's a graphics upgrade for them. So they're not going to see that negatively at all. The third column is virtual GPU. So now we're partitioning each GPU in half, putting 2 users on it, and you get about 4% additional overhead to run the virtual GPU environment. So you've given up 16% total from what a bare metal workstation could be to have a virtual GPU environment. So
was that with this specific profile, or what was the VDGA benchmark that was on?
That's the same Cadalyst benchmark running on a K260Q profile. So you have 2 gigabytes of frame buffer for each user, which is what they were giving them before. This benchmark we did with the K5000 was to get a baseline, but they were actually buying Quadro 4000s that have 2 gigabyte frame buffers. So you actually have the same frame buffer here that the users were accustomed to. Just as interesting insight, this is one customer's data. Your mileage will vary. They ran XenApp in the same mode because AutoCAD's a DirectX app, so it'll run in XenApp. And you get about 60% the performance of a bare metal workstation or 30% less than Xen Desktop. So although XenApp is appealing because of its density, you have to also look at things like, does it give the user experience in terms of performance? And for some apps, it is great. They run XenApp all day, and the users think it's terrific. Some other power users might be unhappy with XenApp because of its overhead.
Numbers for XenApp with the VGPU?
VGPU and XenApp don't get mixed together because XenApp uses Windows Server to manage all of the shared resources. And so we don't partition the GPU. We give the whole GPU in GPU pass-through mode to XenApp, and then Windows Server allocates the resource contention for all the applications that are running. So you actually use a dedicated GPU with either VMware ESX or XenServer, and then you run XenApp on top of it, and XenApp actually has all of the GPU. In a Grid K2 card, XenApp could actually have both GPUs. That's okay also. And then the Windows Server is going to manage, along with the XenApp software, how do I get my users onto the graphics and get their processing done. And that adds overhead, which you can see in this chart.
How does that compare to
So this is 60% of a physical workstation's performance.
that's with the GPU?
That's GPU accelerated XenApp right there, Grid K2 card. So we're using Grid K2 in all of these virtual VDI type environments and XenApp and benchmarks. We just used a K5000 in the physical workstation because it doesn't take a grid card. VSGA, again, has very high overhead because that software API intercept driver from VMware has to translate all the calls from DirectX 10 and 11 down to DirectX 9 before sending them to the NVIDIA card to be processed. And with DirectX 9 going out of support this year with Windows XP going away, that's going to be an issue for a number of applications. So Autodesk is discontinuing DirectX 9 because they think with no XP around, you don't need to keep supporting it, not thinking that there might be a market of people who want to still be on DirectX 9. So just for your thinking, that's happening. VDGA has about the same performance as Xen Desktop. So you'd kind of expect that. It's GPU pass-through. Different, software development team wrote different bits of code, but it's close enough that it's about the same performance. So let's ask the question, what happens when we load multiple VMs on? So we'll take the same card, the K2 card, we'll set the 1 gigabyte frame buffer size, and then we'll stretch it out and see what does that R720 do when you have 8 VMs running simultaneously, and you get about 10% overhead running the Autocad Cadalyst benchmark. So this is an environment where the system is fully busy. You're continuously computing Autocad in all 8 VMs, and the overhead is about 10%. Which, again, I think is reasonable to get 8 VMs simultaneously on that server.
And just a point there, your users are not going to be fully loading that GPU all the time. So this is the worst case scenario that you're going to see. This is 100% of the time AutoCAD running in a benchmark, spinning, doing its thing on those models. Your users are going to be looking up stuff, doing other things, going to get coffee. Not everybody's going to be logged in, so this is definitely the worst case.
So we'll do the same test again, but we'll do it with 16 users. That takes Grid K1 cards to get to 16 users with 1 gigabyte each. And you start to see that the curve changes and your overhead really picks up as you're trying to run 16 VMs simultaneously. So you're starting to run out of other resources in the system like CPU. And so you do encounter a lot more slowdown as you get to higher numbers of VMs simultaneously. So your mileage will vary, but we just want to let you know what we've learned so far from the testing that we've done on how many VMs you're likely to be supporting. To summarize it differently, 2 VMs is about as fast as you're going to go, so I'm calling that 100%. When you get out to 8 VMs, you've only given up 10% of your performance. But when you get out to 16 VMs, you've given up 23% of your performance, about the same as what the other chart said. So it's just something for you to think about. What level of performance is okay with my users, and how far do I want to load it? When you start getting out into these higher numbers, you'll have to go to smaller frame buffers, and that adversely affects performance too. So you'll see that 16 VMs at 1 gigabyte frame buffers versus 16 VMs at a 1/4 gigabyte frame buffer, the performance drops measurably just from going to the smaller frame buffer. So with Autocad, at least, you can see how the performance drops as you start to try to squeeze more users onto the GPU. Most of our customers have concluded that they want to run, for engineering, high-end design type applications, somewhere in the range of 4 to 12 users per server. And that range is going to depend on whether you're doing GPU pass-through. You might be only 4 if you have 2 Grid K2 cards. Or if you're doing virtual GPU, you could get up to 8 or 10 or some number. But at some point, you're going to say, no, the performance drop from CPU contention and other resources is too great. I'm not going to load it any higher than that. So we just want you to have that realistic expectation based on what we're seeing from other people. I'll skip the Revit benchmark. Here's XenApp again. XenApp, we did a lot of the testing before grid cards were even physically available, but I think it still has merit because this particular customer at Bell Helicopter tested both the Quadro 6000s, a year ago, and then when we got him a Grid K2 card last year, he started testing that. The answer didn't change. So what we discovered was adding more GPUs did not speed up XenApp. It went from 1 fast GPU to 2 almost as fast GPUs. And it really didn't change the capacity because he's running out of CPU resources. When Bell continued to load more users onto this thing, above 30, you start to see mouse lag and other symptoms of performance drop. When you get to 50 to 55 users, the server crashes. So I gather from that there's no elegant recovery in Windows if the CPUs start to take so long that things begin timing out or it doesn't get responses it's expecting. And this thing just will crash on you. I have some users that are very happy at 10 users per XenApp with Esri ArcGIS and other applications like that. They're feeling like that's a really great density. It's a great solution for them because when you get into certain apps like GIS apps and oil and gas industry, you have such huge models of data that transporting that data out to workstations is problematic all by itself. The networks aren't fast enough typically, or you can do all the processing, but you can't back the data up because it takes more than overnight to back up these terabyte and double tera and 10 terabyte files. So they really want a centralized solution, and something like this is a way to deliver it to them.
Really comparison on GPU pass-through and XenApp rather than having multiple XenApp servers with the virtual GPU side?
So
You touched on that earlier.
Which does a better job of slicing the GPU? To give a whole GPU to Windows to slice up, or slice the GPU up to multiple Windows servers?
yeah, so we're back in the your mileage will vary question because it's going to depend on the application, your storage, and your network, right? It's not just the graphics that's going to determine the outcome. All the testing I've seen so far says your best performance will be multiple Xen desktop sessions because you're giving a fairly dedicated set of resources to each user. But there are folks that love XenApp. I mean, it's the most widely deployed solution out there, and it will work in a number of applications. It won't work in others. One of my factory floor customers wrote their factory viewer in Direct Draw. It's a Microsoft graphics protocol. They thought this would work fine. They loaded into XenApp and discovered it doesn't run. Well, you contact Microsoft. Windows Server does not support Direct Draw. So you're back in Xen Desktop. So things like that happen to us too, where the apps just don't run well in Windows Server.
And from the Citrix perspective, there's also a significant difference in terms of the protocol. The codec and things like that. There is a significant difference from the app perspective.
Question?
I asked the gentleman in the before, some more questions, but you're saying mileage are what methodologies or facilities are available to help us determine, other than just saying, well, let's buy this and test it and see if it works?
So the state of the art for the last year has been buy it and test it. We have worked with Liquidware and login Lakeside, thank you. And both of them are coming out with GPU test capabilities to measure the actual graphics performance. You can get I think it's a beta still, from Lakeside right now that will do GPU tracking, and it'll track on physical workstations and PCs as well as in the virtual environment, so you can compare. You can also use it to baseline your environment before a VDI implementation and see what graphics is being used by all your applications. So there's some nice things about that tool. All of those tools are brand new and just recently available, or like the beta, I think, from Liquidware was shown at Synergy.
And actually, Login VSI and NVIDIA
Yes.
just created a workload. And you guys are seeing a lot of data on Autocad, right? And I know not everybody uses Autocad, but we had to start somewhere, and we chose Autocad because it's the most prolific engineering application, and it spans most of the industries that we want to be in. So that's why you're seeing AutoCAD data. Now the workloads will also be modified to add different applications and things like that, but that's why you're seeing a lot of AutoCAD data there. You know, what people can do too is some guys will download a CAPS viewer, or do you guys know the Unigen benchmark from the Heaven benchmark, I think it's called, something like that. Not a great app because it's more focused on consumer cards and GeForce and things like that, but you know, there are ways you can kind of get a feel for what you're looking at there that are free and downloadable as well. Okay, we're going to finish up here real quick, and hopefully there'll be enough time for a few more questions. But we got lots of videos. If you want to go check out videos online to be able to see kind of what we showed here, there's some links there. Additionally, we've got a Grid online forum. If you want to ask questions or you want to see what others are doing, there is a forum that we've created called gridforums.nvidia.com. You can go on and get some good info. And more importantly, and probably the best thing to do, is you see the second bullet down. It says there to sign up for a monthly Grid VDI newsletter. We talk about new releases, ISV certification, which I didn't even hit on. I forgot to do it. You know, if it's important to see, is ArcGIS from Esri, you know, a certified platform? Maybe certification for your customers doesn't matter, but in many cases, they want to know it's a certified and blessed solution by the actual ISV vendor themselves. So, you know, we send out updates on what we're certifying in our labs with the OEMs and the ISVs, and so the Grid newsletter also highlights some of the nice wins that are coming on with Grid, and maybe they're in the industry that you're in. And then finally, the Try Grid, the thing that I showed, the little demo there, if you go to nvidia.com/trygrid, you can sign up for it, log in, and experience it for yourself as well, if you want to do that. So with that, I think we'll end and just take a few questions and try to get you guys back on track with your schedule there. Yes, sir. Good question. So, and I may have a slide on it, so let me just see. But with every NVIDIA driver that you install, that's including the one that goes on the host and the one that's going to go in the virtual machine itself, there's a little utility that comes with our drivers called NVIDIA SMI. And if I've got a screenshot of one here, I think it's right here. Yeah, that's it. So NVIDIA SMI comes with our cards. So what it allows you to do, maybe, is it allows you to just run it from a command line. You can loop it, so you can give it a -L option. You can output it to a file, whatever you want to do. And this just kind of gives you an idea specifically right here. And this screenshot's kind of messed up, unfortunately, but that's a heading under GPU utilization. So at any time on a virtual machine, or any time on a host that you want to see what the GPU is actually doing and what utilization it's giving you, you can certainly use NVIDIA-SMI to be able to do that. It won't give any indication of user experience and interactivity. It's just how much that GPU is actually being loaded up at that particular time. It's a, yeah, I mean, I get it, yeah. It is a small executable, so if you can code it in that way to be able to run the executable or to run the shell script, absolutely. But we don't have any ongoing efforts to actually, integrate that to any products or anything.
And basically, we gave an API for this to Lakeside and Liquidware and Login BSI, so that's what they're integrating, is they're using this measurement, but through an API so that they can capture it in their tools.
Yes, sir.
Touched on connectivity, do you envision having
Well, we have a Hyper-V story, but in an API intercept model, right? Think about it from Microsoft's standpoint, right? DX is king, right? That's their graphics API. And so that's the only thing that they're going to support, and they want to have their drivers, interacting with the GPU there. So while I don't foresee Microsoft saying, hey, let's support OpenGL now, I think you might see a solution where we can dedicate perhaps further. We're always talking to Microsoft. They're our biggest partner. We partner with them on the driver level and things like that. But DX is king with them, and right now they just have the API intercept model that they're running on Hyper-V. Okay, all right, sorry guys, ran out of time, but thank you very much. Hopefully you found it interesting.